welcome to today's edition of Math Unlimited, the number-oriented game show. Now, let's meet our contestants.
Hi, my name is Daisy Derivatives, and I got my PhD from MIT in really hard math. And I'm excited to be here today to win lots of money and show off my math skills.
Salutations, I'm Izzy Integral and I hail from Idaho State University where I'm working on a double major in potato farming and superquantum mathematics. Last year I was the youngest ever winner of Math Unlimited and I'm back for more.
What's up, viewers? I'm Otis Optimum. I'm an accountant from Scranton, Pennsylvania. I'm on the show to impress my boss and co-workers from Dunder Mifflin Paper Company. This is for you, Phyllis.
Alright, fingers on the buzzers. Now, when solving rational functions approaching infinity, if the degree of the numerator is equal to the degree of the denominator, then what is the limit?
The ratio of two leading coefficients.
Ding ding, 10 points for you. Now, if the degree of the denominator is less than the degree of the numerator, what is the limit?
If the limit never approaches anything, the limit does not exist. The limit does not exist!
The limit does not exist!
Correct again. Now, Daisy's count is 20 points, thus putting her in the lead. Now, if the degree of the numerator is thus less than the degree of the denominator, what is the limit?
0.
You are correct! And now, for the second part of today's show, curve sketching! Your problem is... Now, sketch that curve. Oh wow, Izzy, I believe that you are much more qualified than our other contestants because, as you can see, she took the first derivative, something none of our other contestants have had. And look at that, we got f prime of x is equal to 20x over x squared minus 4, all of that squared, in order to find our critical numbers, which she has not yet found. Oh, ooh, I should not have said that. Either way, she found the second derivative too, and she's very, very successful. And look how she found the x-intercept. She just plugged it right into 0. Well, not plugged it into 0, but set it equal to it so that her x-intercept is negative 3, 0, and 3, 0. For her y-intercept, she just plugged in 0 and got 9 over 2. So our vertex is 0, 9 over 2. And our vertical asymptote, we have x squared minus 4, so we get x is equal to negative 2 and positive. And just look at how she solved for the x, y, and vertical asymptote. For the x, she just set the entire thing equal to 0, so she found that her x-intercept was negative 3, 0, and 3, 0. While for the y-intercept, she just plugged in 0 and she got 9 over 2, as you can see. And for her vertical asymptote, she just set the bottom equal to 0, and she got that it was at negative 2 and positive 2. You got it, Izzy. Just keep going. All right. Well, we resent the fact that she did not show her work, but then again, Otis and Daisy, they weren't, Anyway, she found that the horizontal asymptote was y equals 2 because of the degree of the original problem. As for the critical numbers, we just set it equal to 0, we got that x is equal to 0, and that it is decreasing when you plug it back in to the original equation. And we found that it was decreasing and then increasing, which means we have a minimum at that point. As for points of inflection, she plugged it in and she found none, and that the intervals, it is from negative 2 to negative infinity, negative 2 to 0, 0 to 2, 2 to infinity. Let's see what happens next as she graphs this incredible drawing. She has pointed it out. She has drawn it perfectly. This is absolutely beautiful, and she's drawing out the asymptotes right now. Can you see them at 2 and -2? She has a point here at 9/20, and it is just absolutely well done, Izzy. Well done, Izzy. Full points to her. She may not be done, but wow, this is incredible. Izzy, smile at the camera. You just got a full 30 points. You are now winning. Time for a final round, optimization problems. Since optimization is the last round of today's show, the contestant who gets the problem correct first will get a bonus of 50 points. Markers ready? Let's begin.
Let's do it! Yeah, push it to the limit, cause we're in it to win it, oh yeah, I'm real.
Congratulations, Otis. Do you have anything to say to your folks back at home?
Yes, I want to thank all my co-workers back at Dunder Mifflin, especially you, Phyllis Vance.
That's all, folks.